So today we are going to be building our very own AI voice agent that you can run locally on your computer, and you can use it to control a whole variety of different things. In this example, we'll be using it as a shopping assistant, really just to demonstrate how the functionality works. But then you could connect this to external APIs, different products and services to actually fully enable systems to be voice controlled. AI agents are one of the hottest topics at the moment. And as you may have seen from emerging technology, AI is becoming prevalent in genuinely fulfilling things that people need to do in everyday life, such as answering emails, doing outbound sales, fulfilling manual work, helping you to run your business, and in this case, literally being a co-pilot that can run alongside you. So let's jump in. First things first, as with all of these tutorials, all the code, including step-by-step setup instructions, a walkthrough of the code repository, and full documentation is provided on the GitHub repository that will be posted in the description below. You can also follow code creations on GitHub and feel free to fork and reproduce this code however you wish. This is completely free and open source. So let's get started. Now, in terms of setup, I've tested this on a Windows machine. This will work on other machines, but I haven't fully tested it on other operating systems. Feel free to test it as you wish. The first few steps are really just installing all the various packages within a virtual environment in Python. I'm going to switch over to Visual Studio Code and get started on that. So I'm going to open up a terminal. I'm going to create a virtual environment. I've already installed the virtual environment package, so I'm not going to do that. If you're familiar with Python, this will be a fairly standard thing that you'll do. I'm then just going to activate this environment. The command for this is slightly different than the command on Mac, but it's a fairly similar process. So now I'm in the virtual environment. Now let me install the requirements. Okay, all the requirements are now installed. So if I go back to the repository, what I've included here is a walkthrough of how to run this repository. So if you literally just want to clone the repository, install the requirements, and then run the application, you can do that. Or what we're going to do is we're going to go through all of the code and how it all works. But you can also just clone the repository and run the main file, which will then actually run the application for you. In terms of the technology stack, we're using OpenAI as the underlying LLM. You can switch this out for another LLM if you wish. A big part of this application is the ability for you to use your voice to control your computer and the computer to actually speak back to you. So to enable all of this, we're using PyTTSX3 for text to speech. This is going to be used by the computer to then speak back to you. And for us to speak to the computer, we're using the speech recognition library and the Google Speech API. So speech recognition will be recognizing our voice from the microphone. Google Speech API will be transforming our audio into text. And then a few other packages we're going to use to improve the overall user experience. First of all, threading. Python as a language is blocking, which means that when you perform operations, one operation can't be performed until the previous operation has been completed. If there's an operation which is taking a long time to execute, it's going to block everything else from executing after it. A language like JavaScript, for example, is non-blocking, and it allows you to execute things in parallel. And therefore, to get around this issue, we're going to use the threading library. And what this allows us to do is to run different processes in different threads. We can both speak to the computer and the computer can speak back to us. We can give multiple requests to the computer at once. Rather than it all just getting stuck because it's currently processing one operation, it will add all these operations to a queue, and these operations will get executed in different threads. We're then also going to use Pydantic. This is very useful when using LLMs in order to strict type the outputs that are coming out. And to make use of the OpenAI API, we're going to need an API key, which you, of course, can obtain for yourself. And we're just going to use the python.env package to load that environment variable. So we've already done all of this. So I'm now going to skip to creating the AI class. So if I come back to the code, you'll notice that I've organized the code in various different files and folders. Within the classes file, we have the AI class here. If I open up this file, okay, so we've created our virtual environment, we've installed the packages. Now we're going to run through actually implementing the code. So what I've done in my Visual Studio Code is I've cleared all of the files that contain code, and I'm going to copy it chunk by chunk over into Visual Studio Code and explain to you exactly what's happening. First of all, we're going to create the AI class in the ai.py file. This is simply loading the packages and declaring some strict typings that we're going to use for the OpenAI LLM. This example is focused around somebody making a shopping order. So I've declared two different classes here for our types. We've got a basket, which includes the name of an item that I'm ordering and the quantity of that item. And then we've got the results, which is the results of a query that I make to the LLM. So that includes the intent that I'm actually asking about. So it could be I'm adding an item, I'm removing an item, I'm updating an item, I want to reset my basket, or I'm actually done. And it includes the overall basket as well, which includes all my orders of items and their quantities. Now we've declared that, we can create the LLM class. Generally, when I write my code and applications like this, I like to wrap my code in classes. Not only is it best practice, but it's also really good for reusability and for debugging. Especially as you start to write more production level code, object-oriented programming is really important. I imported this chunk of code for the LLM Manager. As you can see, within the properties, I'm defining a few variables here. This first one is the intents. These are all the different intents that this AI voice agent can handle. So it's going to allow me to add an item, remove an item, update the quantity, clear the basket, exit the conversation to identify if the query is invalid, check out, reset my basket, and start the ordering process. Now you can change these intents to whatever you want, but the reason why these are important is because when I set up the LLM, I'll instruct the LLM that these are the only things that this LLM needs to be able to handle. Anything else outside of these will fall into the invalid query intent. And this way, it will then constrain the LLM from going off and trying to fulfill a completely different type of query. This keeps the LLM within a certain boundary. I've then defined some products that I'm going to ask for. In this case, I've got some video games, Pokemon merch, technology, and consoles. I've also included synonyms for all of these items. This is optional. You can use the LLM to think about these synonyms themselves, but I find that giving the LLM some further instruction and some further indication as to the different ways that people can ask for things, especially as you start to work with much more nuanced conversations, this is also quite useful as well. And then we're literally just initializing the class. This is literally just opening up, instantiating the OpenAI class and creating some global variables. The next method is the process user input method. This is where we're actually going to call the LLM and instruct it with our prompt. So I've constructed this prompt, and this format for prompts works really well. Giving it clear instructions and clear sections to your prompt definitely can help. In terms of the context, it's a shopping assistant chatbot. The user will give commands to add, remove, or update items in their basket. And it's your role to keep track of the basket. Making it clear in terms of steps that the AI has to follow is also a really good best practice. For example, as your role, you must process the user's query and you update the basket based on that query. These are the different intents that you need to handle, which we've already detailed. Then giving it steps, logical steps it has to go through when we're asking it to do something. So for this example, it includes processing the user's query, updating the current basket based on the query, and then returning the results in the specified valid JSON. And then finally, any rules that the LLM should follow are really important to define as well. In this example, I'm telling it to output the response in a valid JSON format. You need to handle irrelevant queries gracefully. I'm instructing it that it needs to use the data that I've provided in the products and the synonyms to match my query to products. And if the product that I'm asking for is not relevant, then ignore it, essentially. If you're familiar with using LLM APIs, then this code should look fairly familiar. Simply creating some messages that we're going to be sending to the chat completions API, defining the model. In this case, I'm just using a very lightweight and cheap model, ChatGPT 4o Mini. You can obviously swap this out for whichever you want. Now, the temperature is quite important because the temperature generally decides how creative or outside of the box your LLM will be thinking. In this case, I don't need the LLM to think particularly creatively. I literally just need it to analyze what I'm saying. So I don't want it to be thinking outside of the box. Therefore, I'm setting it to 0, which should make it much more reserved. And then this final block of code here is essentially just passing the result from the LLM. So that is everything that we need for the AI LLM Manager class. Now we're going to switch over to the conversation file. We'll make our imports. So these are all the packages that I mentioned before. We've got the text-to-speech package, we've got the threading package, and we've got the speech recognition package. And let's start building our conversation class. So this conversation class is going to manage the conversation with the computer. It's also going to manage the lifetime for which the microphone is open and how all of the speech inputs that I provide is added to the queue, and then how this queue is then processed as well. So a few things that I'm initializing here. I'm going to initialize a flag, which will then tell the conversation manager when to stop listening. So when we initialize this conversation manager, it'll be set to false, meaning that it should start listening. But then there'll be a few different instances within the code where this flag will then be changed to true, which will then mean that the conversation manager can stop listening and the microphone can be closed. This energy threshold is quite an important property, and this is used by the speech recognition library basically to initialize and to calibrate the microphone when the microphone is opened. Energy in this case is kind of a measure of how much noise or activity is going on around the microphone. So therefore, when we open up the microphone, you'll notice that the microphone does a bit of calibration. And this is really to try and block out any noise that's around the mic. We've then got our speech queue here, which will store the queue of all of the processes that need to be executed. And we're also going to initialize the LLM Manager here as well. The next thing that we're going to add is the continuous listen method. There's several helper methods that I'm going to include in this class, and then there's only one method that we'll use in the actual main file. All of these helper methods will essentially be used to run the whole application. What's happening here is that when this method is called, it opens up the speech recognizer, it opens up the microphone, and it also sets the energy threshold that we decided before. We then define another function within this method, which is essentially our continuous listening loop. When this is running, as you can see here, it will adjust for ambient noise. It uses a certain threshold of time to take in the noise around the microphone, and it will adjust the sensitivity of the speech recognition based on the surrounding noise. As you can see from this while loop here, this is basically going to carry on continuously until the stop listening flag gets changed to true. And what's happening here is that the audio is being recognized by the speech recognition library. It's then passing it to the Google Speech API, which is then converting that audio into text. And one nice benefit of the way that I've set this up is that the audio is not being saved locally on the machine. You can use other libraries and this library as well to save the files on the machine, but this is intended to be as lightweight as possible. So actually the raw audio is sent to Google, and then Google is transforming that into text. Then we get our transcript, and this transcript is added to our speech queue. And once this gets added to the speech queue, then it will be processed using the threads. We have some error handling at the bottom here as well. And then finally, outside of the listen loop, we're just initializing the listen loop in a separate thread, which will allow it to be executed in the background. So the next helper method is the process speech method. Now what's going on here is, once again, we have another while loop. While we are listening, we take the transcript from the queue. This is constantly waiting for a transcript to be added to the queue. As soon as a transcript is added to the queue, all of this remaining code is then executed. First of all, it checks to make sure that there is actually some valid text on the transcript. If not, then it will come back with some error handling. If there is valid text, then it's going to send the text to the LLM Manager using the method that we set up before. So if I just click through on this, go to process user input, the transcript is then being sent to this method here, along with the current basket that the LLM Manager is maintaining. When we get the response back, we extract the intent from the response. And this is obviously based off the JSON structure that we're asking the LLM to provide back to us. And based on the intent, we're taking various actions. So for example, if the query is invalid, the computer will say, this is an invalid query, try something else. And then we can add as many different blocks here as we want for all the different intents. For each of these intents, various things are happening, such as if I clear the basket, it's going to reset the basket and start again. And if I'm adding or updating an item, then the basket will get updated as well. And this is handled at the bottom here. I also have an intent to be able to exit the application, which will break the loop, update the stop listening flag to true, and exit the application. So this method handles what the computer is doing once it receives the response from the LLM. Finally, there's two other helper methods that I'm going to add. You may have seen some of these helper methods being used already, which I'm going to explain now. We have a speak response method. And let me just uncomment these lines here. This speak response method, as I said to you, with this application that you can run on your computer, you can speak to the computer and the computer can actually speak back to you. The computer is going to be using a very basic voice, but you can swap this out for any other kind of voice that you want to, or audio files if you wish. So this speak response method will provide a spoken response back to me as the user based on the intent I have just requested. And once again, this is all being executed in the background in a separate thread, which means that it's non-blocking. So if the computer happens to be speaking to me and I decide that I want to start speaking back to it, it will be listening at the same time as it's talking. And then finally, the save state method. This is just a simple helper method that when I make a request to the computer, it will save the current request in this response.json file locally on your computer. So you can keep opening this up to check what the computer is processing. So that's all the helper methods. The last thing that we need to copy over is the start method. And this is the actual main entry point that we'll use to run the application in terms of this class at least. So I'm going to put this at the top. Essentially what this is doing is it's calling the continuous listen method. It's adding another thread for the speech events. And then it's basically setting up a continuous listening loop until somebody says that they no longer want to use the application or exits the application. So that's all the code that we need in the conversation class. Finally, we're going to fill in the main module, which will be the entry point that we use from the terminal. This is very simple. This is just importing the various classes that we've created and setting up the module so that we instantiate the classes, we instantiate the queue as well, and then we start the conversation manager. This makes for a really concise and clean entry point for our application. Everything is abstracted away in these various classes. So now let's get started. I'm going to close these files and show you how this works. I'm going to increase the size of this terminal because this does run off of the terminal, off of the command line. So to run the application, you simply do python.main and run the Python file. Can I get a Nintendo Switch? I want a PlayStation. Can you give me 3 more PlayStations? I'd also like an iPad. Actually, remove the iPad. Okay, I'm ready to pay. Thanks, I'm done. So obviously I couldn't commentate whilst I was making those voice requests, but what you can do, which I couldn't do because I'm recording my voice, you can turn off your microphone and then the application will just run in the background waiting for you to then unmute your microphone and speak to the application again. So I demonstrated a few different pieces of functionality there. If I come to when I started running the code, notice that the microphone was preparing and calibrating for the ambient noise. And it actually gives you a numeric indication of what the ambient noise levels are in the background. So it does this calibration at the start, basically just to ensure quality audio is being recorded by the speech recognizer. Now I'm in a fairly quiet room at the moment, so the energy threshold was very low, which most likely helped with the fact that I was being able to get very accurate voice transcriptions. So obviously this is a shopping voice agent based around the different products that I've added into the code. You can change these products, you can add more products, you can do what you want with it really. So you can see that the system was able to transcribe what I was saying. It tells me, you said this, can I get a Nintendo Switch? It then passes this information over to the LLM and the LLM decides what the intent is and it updates the basket accordingly. So it's updated it with the item name and the quantity, which is perfect. I then asked for another item, the PlayStation. Notice that I said PlayStation, not PlayStation 5. That's because of the synonyms that I added. Once again, it identified this as an add item intent, and it added this to my basket, which was great. Then said I want 3 more PlayStations. So the intent is different this time. It's now update the quantity of an item. The quantity of the PlayStation 5 was 1 before, but now it's 4, which is brilliant. Once again, the LLM was able to update the basket in this way. I added an iPad. So now I've got an iPad in my basket. And then I removed the iPad. And once again, it worked really well in terms of removing the iPad from the basket. Then I said, okay, I'm ready to pay. Because one of the intents that I programmed this for is to be able to handle when somebody wants to check out. Now, I might do another video on how to actually connect this with a payment gateway. Obviously, for this example, it's not connected to a payment gateway. It just identifies the intent and then prints out the basket. But if that's something of interest, then I can definitely do that. And then I exit the application. I'm done. The microphone closes and the Python module has been executed and exited. This is a very simple example of how you can get a computer to not only respond when you talk to it, but also have the computer speak back as well. If you're able to run this on your computer and you have a speaker next to your computer, then the computer will actually speak those responses back to you. And when looking at this code and watching this video, really start to think about how else this can be used. This is a simple application that is very modular. You can integrate this into applications. You can integrate this into services. You can integrate this even into websites. And when this becomes really powerful is when you connect this to other services as well. So for example, if you were to start connecting it to a kitchen management system or a CRM system, and when you start to think about the different intents that are being handled here, when each of these intents is triggered, you can have an operation that another AI agent could execute. So for example, okay, I'm adding an item here. Right, now I need to add this order to our back-end sales system, or I need this system to go out and find the average price for this item on Amazon or Alibaba, for example. So this is really just a foundation of how you can build a voice agent locally on your computer. You could even use this in a way to start to control your computer as well. For example, asking it to open up a web browser or go to this website or answer emails, that sort of thing. So hopefully this has given you some insight into how you can build your own voice agents to control your own computer. And this has given you a foundation upon which you can start to integrate voice agents into various different products, services, businesses, websites, and your overall processes and workflows. Would love to hear your thoughts on the video, and if you have any other ideas that you'd like me to cover, then please comment them down below. But for now, I'll see you soon.